Well, good afternoon, everyone, and welcome to our webinar today, where we're going to take a look at the Advanced Assembly Extension for PTC Creo. And what the uniqueness of this extension is that it allows you to improve collaboration with other people that are working on the same project, same CAD files or assembly. You'll hear a phrase, a change made in one place is a change made everywhere. And also helps you to design from skeleton models. So this is definitely a way to get you a much better model for manufacturing purposes also. So without further ado, we're going to have Paul Dye from the Virtual Center of Excellence at PTC, who's an applications engineer and a solution consultant. Paul's going to give us a presentation today on the Advanced Assembly Extension, and he will then give us a demonstration. If you have any questions, please put those in the chat box. My name is Rob Romanowski. I'm your host today from 3HTI. And Paul, you can have the con and take it away.
All right.
And we see your screen.
Awesome. Good to go. Well, thank you very much, Rob, for having me on, and thank you everybody else for joining. So really happy to be on talking today about the Advanced Assembly Extension. I've said in years past that this is the most important extension in Creo, and it's even more so nowadays, right? I think every single year that you see new products being introduced and really new things being designed, this is becoming more and more necessary out in the industry. So there's a lot of different challenges that we look to address with this. I'll go through and explain all of that. I'll go through and explain all the capabilities that we have around advanced assembly, walk through a few different examples from within the context of Creo. And if you have any questions throughout, feel free to drop those in the chat box in the Q&A. We'll make sure to get to anything that you have questions around. So without further ado, we can get ahead and get right into it. So first thing I like to always discuss is around the challenges that we typically see when you're working with specifically larger assemblies or just more complex assemblies. You're oftentimes going to have multiple people or multiple times working on that design, and you need to be able to work together. You need to be able to share information, keep everybody on the same page, and need to be able to control the process. The last thing that you want is two people that are trying to work on the same thing or moving in opposite directions. And what we see is oftentimes as those assemblies get larger, they get more complex, you see those losses in productivity just becoming larger and larger as well. Some teams that you work with oftentimes aren't even going to be inside of your company. It could be outside partners, suppliers. They need information. You may need to make sure that their information is matching up with your information. But at the same time, you might not want to share all of your intellectual property with those outside companies. You need to be able to keep it secure. You still be able to transfer the information that you need. And really, traditionally, we see CAD tools be very limited whenever it comes to working with those types of designs. Whenever you're working on a design with 10, 15, 20 other people, you really can't work with a bottom-up approach as things start to scale. You really need dedicated tools to assist you there. And if you don't have a system in place to be able to work with those type of assemblies, it can be slow. It can be very tedious to plan, to document, to assemble the designs. So these are all challenges that we need to be able to address, and really things that we have a solution to in Creo with the Advanced Assembly Extension. You may have heard this referred to as AAX in the past, or top-down design methodology, but really what this extension is doing is giving you tools specifically built out to combat a lot of the challenges that we see with larger, more complex assemblies. And what we're looking to do is speed up the assembly process with your design team, the outside teams, even down to manufacturing. And then from there, being able to effectively manage everything throughout the design. Now, I've kind of hinted at this, but it really starts with the idea of top-down design, being able to plan out the framework for how an assembly is going to go together, what it's going to look like, have that planned out from the beginning. That starts with the idea of skeleton models. These are really laying the framework for specific functional areas of the assembly that we're going to be working on. Gives you the ability to share and work with only the areas that you're concerned with. You also have a reference viewer here from within Advanced Assembly that we use for viewing and also managing all of the different references that we're working with, and really only, I'll say, define the different references and dependencies for the parts that you need. Could be parts, assemblies, sub-assemblies, really have that all laid out. And also full control over those references in the model. So defining what the scope is for the model, where each part is connecting together, we really want to manage those references so the models are more flexible over time. Now, it's also working around the idea of concurrent design, which is also fairly similar, but the idea is with this that we're going to be working together. So you might have one designer or engineer, like you see here over on the left, that might be your lead integrator or your lead designer for a project. In this case, it could be for the design of a knife. And what you're doing is sharing out specific pieces of geometry to different areas and different members of the team. So one person might get certain curves or surfaces for the handle, one might get certain pieces of the geometry for the knife, for the switch mechanism, and even certain parts out to suppliers. And then, say, for example, you're doing a design review and you want to change what the overall radius of that knife looks like. Or you say, I want to look what this knife would look like with 3 notches for the fingers instead of 2. Well, that's something that you can much now, I'd say, easier and much more efficiently share these things out and get those changes propagated down to different members of the team, being that you started from that top-down design approach. You're able to do more of that concurrent work and design at the same time. This also uses, I'll say, what we call inheritance models. This is controlling whenever you make changes to certain parts or subassemblies at the top, whether or not those changes then get propagated down the line, or vice versa. If you make a change to this inheritance model that you have defined down the line, that doesn't affect anything from the top down. So this is really, I'll say, a essential part of what we do for things like assembly models, when we work with analysis models, whenever you're even doing manufacturing models. Sometimes you have to do things like shrinkage for manufacturing. These are all very useful for using inheritance models. Another thing that we oftentimes work with here is assembly configuration. We have tools such as interchange groups for things like fastener attachments, where they're always going to go on the same way. You shouldn't have to spend time setting each one up individually. So if it's something like a custom electronic fitting where you're just trying to make it mount, you're just able to pick the face that goes on and have that all laid out there for you. Also swapping parts out like design to order. This is where you're starting with a standard configuration, but you have 5 particular pieces that could be swapped out depending on a customer's orders. So you might never build one particular configuration, but you're always ready to go in an instant to go ahead and get that new configuration out to a user based on what the order is. You also want to be able to define process planning, understanding how that model is going to go together whenever you're putting it out into the field. Well, with that, you need graphics, you need bill of materials, all the things that you need to do for manufacturing to show how this is going to go together and doing this level of process planning. In order to do that, you really need and to define that from your engineering information. You don't have to recreate that. You can have it really be automated through the work that you're doing in advanced assembly. And this really plays in with very well with the tools that we have, visualization and performance management. If you have a big assembly, we see customers in Creo working with 10,000 part assemblies, 100,000 part assemblies. That can be a huge amount of data that your computer has to crunch. Well, we give you tools to really control that. If you only want to look in the specific area, you can turn those other areas off or set these different areas to lower levels of representations. We also have tools like shrink wraps, for example, that reduce the time that it takes to load up, to put to memory and work with it. So these are all capabilities that are working well from within the Advanced Assembly Extension. From here, I want to go through and show what this actually looks like from the context of Creo. This will help to give a bit of, let's say, context for exactly what I'm talking about here and really help to cement some of the different ideas that I'm hitting on here. So again, if you have any questions or if there's anything that you'd like me to explain further, feel free to drop that in the Q&A and I'd be more than happy to do so. Right, so for our demonstration here, we're going to be working with a train assembly. Obviously, anything remotely approaching the size of a train is going to be a large model. As you can see, we have a lot of pieces, a lot of work from start to finish here that we're going to need to do. Even if we were to just break it down to a particular car or locomotive, it's a lot of geometry. And advanced assembly is all about managing that model, keeping track of whenever you're working among your teams, who's controlling particular geometry, who's working on certain areas. That's what advanced assembly or AAX is all about. A lot of it revolves around this idea of a skeleton model. Skeleton model could be lines, arcs, curved surfaces, anything that you want to use to set the overall control for the model. And the idea is once you have that skeleton model, I can go in here and say, okay, we're going to take a certain set of surfaces, curves, and I'm going to publish out that geometry and use them for particular uses. In this case, it might be for our structural components. And then even using that same skeleton model, we'll go ahead and create another set of published geometry. Maybe in this case, it's going to be for some of our interior components. So we might take a few other sets of curves. It's really whatever makes sense. Lines, arcs, points, whatever references that you're going to use downstream. And our interior might be useful to get that door frame or the window frame. And then we'll publish that out for our interior components. And so that's what you'll see. We're specifically grouping using that published geometry, giving them a name so they're easier to find later on. And we could feed those down to the different areas of the different users that would need them. So here we have our structural model. Inside of here, we'll also go ahead and grab that geometry that we published out here for our structural components. And then same thing here for the interior assembly. We're just going to go ahead and copy the geometry that we have from before. That'll be our 4 interior components that we published out from earlier. And so publishing them out from the top and then copying them into the specific functional areas that you need to be working with them. So you don't have to load up all the rest of that geometry. We can just simply go work here in our structural model. Somebody else in the team could be working on the interior. We're not getting in each other's ways. And that's really because the skeleton that's coming from that top level is controlling the work that we're doing here. In this case here, we can go ahead and do some work. I know I need to add in some additional support hoops here to help that structure. I can just simply take the curve that we pulled in from the master and do a sweep of that shape just to show you what this would look like. We'll sweep that section along our curve here, and now I have my beam profile. And from there, it's really just standard Creo work. Cut out where the upper support structure goes, shell out to a different shape, whatever you're going to do, just some standard CAD work. And the idea still is that the master overall shape is being controlled from that top level skeleton geometry. And that's what Advanced Assembly is all about. It's making it very easy to make those connections, to control them. And as you can see here, changing them, doing work off of them. You can pattern that hoop along the length of the cart, modify the spacing as we need to. And I think that looks good for our support structure. Got my new hoops added in there, got all my geometry. So I can go back here and turn on the rest of my structural assembly. And in this case, what you'll see is I'm using lightweight representations. If I don't need to see all of that part or just certain parts in particular, just turn that off. And from here, we're going to go ahead and work on the interior subassembly. This could potentially be someone else on the team, right? Or it could just be me if I need to build out something on the wall here, work with just a piece of this. In this case here, I have this existing wall and I'm going to punch out where the window needs to go. And in order to do that, I need to know what's the size, what's the shape of the window. And to do that, I'll just use the geometry that we pulled in from the skeleton. We'll go ahead and grab that loop. That's what we're going to use to make our form feature. We're going to go ahead and assume this is a sheet metal piece. It'll be punched out, so we'll just give it some thickness there. And in this case, I'm giving it a bit extra because I know I'm going to trim it down based on the curve that we pulled in from the master model. Just quickly give it a taper, round off some of those hard edges. And it's going to come out a little bit further than we need to, so we'll go ahead and cut that down. Still using the copy geometry that we pulled in from the master to control that, but here, again, using it inside of my work. And if there were ever any changes to that geometry, that would immediately be able to be propagated down the line to this interior subassembly. All right, that's looking pretty good. We have windows so our passengers can see out of the train. Definitely a good step there. Go ahead and turn those other walls back on, regenerate the model, and we're good to move on. So let's stop back here into the top level assembly. If we're working in the top level, maybe you'll set some of these lower levels to a simpler, more graphical representation without all of that data being loaded up. And from here, we can go ahead and keep working on the doors. And this is the same sort of thing. I have my skeleton model inside of my door assembly. In this case here, I actually also have a shrink wrap of the rest of the geometry. I want to be working on my door, but I still need to see the rest of that in context, but not necessarily needing to load up the entire car assembly. I can bring in things like the shrink wrap of the existing floor structure and just work around it. And now from here, we'll use some of our copy geometry from before. But in this case, what I want to show you is our ability to control what we're doing here. So up until this point, any of the changes that we've made or anything that we would want to have changed would just automatically be pushed down the line. But what you'll see is that we have a few different options here. So what we're able to do is Instead, set this to be a manual update with a notification. So if something were to change later on to that master model, instead of automatically updating what we're going to go through and change here, instead what it would do is leave it as is and simply give me a notification that something's been changed. So this will make a little bit more sense as we go into later parts of the demonstration here. But in this case, we'll go ahead and do a little bit more modeling. So this will be that surface feature, the surface quilt that we copied in from the skeleton. We'll make our door out of it. Go ahead and give it a little bit of thickness there, cut out some of the windows, see how that's going to look. All right, it's looking pretty good. We had the base structure there for the interior door. Again, still defined, same way as before from the master skeleton model that's controlling all of that. We'll set that to our master representation so we can see all of our geometry here. And that's looking pretty good. All right, so again, that's really the power of the Advanced Assembly Extension. It's allowing me to set these different levels of representations, allow me to copy geometry, set up skeletons, control everything. And that really is what you need to do in order to work with models that are getting to this level of complexity. Otherwise, you're going to have so many issues in front of you. And now that I've set my model up to be controlled, what I can do now is go through and make some changes. One of the best ways that we have of doing this from within the context of Creo as well is using what we call the design exploration extension. This is something that I always like to show users and anyone that's working on, I'd say more recent versions of Creo, you already have access to this. And this is something that you're able to use not only just in advanced assembly, but really anywhere from within Creo. And it's helping you to do iterative design work instead of what you would normally do, where you might just do every time you make an iterative change, you do a file, save as, and make a copy. None of that. Instead, what we're doing is just simply working with that overall model, starting into a design exploration session. Instead of making copies all the time, we're instead working within a streamlined checkpoint tree that allows you to go through and make whatever iterative design changes that you want, build out branches and checkpoints throughout that design process, and then always reference back to that. So you can go through, lay out multiple different iterations, multiple different design paths, and you're not making new models every single time. And I can show you a little bit about what this looks like here. In this case here, let's go ahead into our overall skeleton model. And this is going to be probably a very likely situation. In this case, maybe you go through a design review and you say, we need to add in a taper here. We want to make sure that we're minimizing the amount of material that we're using, make sure that's not going to I'd say, interfere with anything around it. And what is that going to do then to everything that we've designed based off of this, right? It obviously has a lot of different effects. Well, in this case here, you can just see that everything changes because it was defined from that skeleton. And actually, it looks like one thing wasn't automatically updated, and that's actually because earlier we had set it to be manually updated with a notification, right? So what we're able to do here now is say, hey, Creo, show me the differences. And it's going to show you exactly here what's been outdated from before, now what's been changed. And so you can have that level of review before you have things going through an update. So it doesn't have to be everything updates automatically, everything's automatic. You can have that level of manual control. And like you see here, go through with the design exploration, build out a checkpoint there, and that's something that you can always reference back to later on. All right, and here we can go ahead and keep moving on to our passenger car. We'll open up a cross section here so you can see what's going on inside. And I want to go through and make some changes. And really, this just becomes your normal Creo work. Maybe you need to make a change to the armrest, whatever it might be. The design exploration is essentially going to watch the changes that you're making, allows you to say what you like, what you don't like, and clearly show exactly what happened. In this case here, going to be changing the armrest. If you add a feature, if you reorient it, it's just keeping track of all that for me. You know, I have these tools to help me if you're doing more complex work, see exactly the changes that we're making here. You know, do you want to keep it? If you do, and you're happy with the change, let's just go ahead and make a checkpoint. Just make that wherever you made that change. And the idea is that you don't necessarily have to keep it. It's not doing a save as or making new names. You know, at any point I could say, hey, I want to revert back to a different checkpoint. You know, and from that point, you can make branches off of there, make more changes, just do your standard type of work. And that's what we can do here. We can activate that shell change and we can revert back and the seats would just be right back to the way that they were. And that'll be true for any sort of change that you're going to make. And even if you wanted to at some point go forward with the design that you've gone through and made changes to, you just say okay, and now you have that new shape, you got the new profile for the cart. Again, all being controlled of the work that we're doing with advanced assembly. So it really gives me the ability to work with these larger assemblies a lot more quickly and have a lot more control throughout that process as well. All right. So any questions from that? Any thing that I can maybe explain a little bit further based on anything that I covered there?
Yeah, Paul. So we have a Creo user that has submitted a question that basically says having assemblies on a step format and as a part is sometimes troublesome to perform an analysis like DFAs or provide design proposals to a customer. So then the question is, how can I separate the assembly on a step file to have all the parts separated?
Okay, so you're essentially, I guess I want to understand the question a little bit more. So is
Mhm.
the question that you'd like to not have it saved out all as a single model, where it's kind of just taking an assembly and putting it all into a single file without that part structure in the assembly? Or are you looking to maintain that structure, but still save it off as a step file? Because that is something that you're able to do. You are able to go through and build out a step file that still has those different structures from within the assembly and sub-assemblies all laid out. So
Yeah,
you
can
can't.
all the parts would be separate. Um,
Okay. So
so
you're
he's saying
receiving
he receives
files.
files in a format to perform the analysis.
Okay, so you're getting those files and you'd like to take them in and perform the analysis from within Creo. I'm assuming that you're saying that you use analysis features from within Creo. Is that correct, Hugo? Okay, gotcha.
That is
Yeah.
correct.
So it seems like that's just simply an issue from the people that are sending you the files, right? So if they're sending it to you in a format where they've taken the files and condensed them into a single model, well, then that's just what you're working with, right? That's essentially an issue with the models that are being provided with you. Creo is able to go through and take step files or IGES files that have those different structures still defined, right? You don't have to go through and take in models that have been condensed into a singular model essentially. So that would be something that I would probably talk to the people that you're getting the files from, right? So if they're simply sending you a file that has that all condensed into a single model, well, that's going to be an issue. You can still take those into Creo and split the bodies and do work such as that to get them all breaking up. But I'd say a better solution would be to get the models into a format where that structure is still maintained, because Creo is able to work with that. And then that would be a lot easier to go through and work with from within your analysis, because that's definitely something that Creo can do.
Cool. Good stuff, Paul.
Yeah. And again, just a couple last things that I really like to make sure that I hit home on here, because it's one thing to see it in action and one thing to see that it might be nice to have. But really, for a lot of people, this is a need to have. And there's a lot of reasons that it is a need to have. First and foremost, do you want to be able to reduce your time to market? Well, I'd say in most cases, yes. It's something that if you're all able to work together in a much more streamlined product development system, get your products out to market a lot much faster, that's really what advanced assembly is enabling you to do. It's something that you're able to go through and build out better quality. You're not going to have things that get out to the shop floor just for you to put it together and ultimately realize that it's not going to work, which is a huge problem with bottom up design, right? So if you're able to do top down design, it's really helping with that. And the same thing with supplier products, that if you would be able to share enough information and get the amount of information out that you need, you'd be able to get things to work the first time around. So getting product quality is really important there. And also putting those together, you're really starting to divine and developing into new markets. You're able to try out new things, try out more variations of assemblies that you've created. If you want to use design exploration in order to facilitate that type of work, these are all things that you can control still using that advanced assembly process. All right, and with that, that's all I really had to go through and share. There's obviously a lot more that goes into this extension and things that we could definitely dive into more, but really just wanted to give you that brief overview and introduction into the tool. So with that, I could pass it over to you, Rob.
Cool. As always, Paul, excellent job. Excellent job. So if you have any questions about this webinar, all you have to do is reply to the email that you received from me, and I will receive that email directly in my inbox. So if you have any questions or need anything, you can contact me that way, or you can contact us at info@3hti.com, real simple, info@3hti.com. Or you could call me at 610-590-1089. So you will receive the recording link up on our YouTube page by tomorrow, so you can view this at your leisure. Now, next week, we're going to have our webinar at 11 instead of noon. We're going to have it at 11, and we're going to have industry veteran Gary Hoffman review the Creo packages and what's included in each Creo package. A lot of times people think, oh, well, this package, that package, Creo, there might be, you might understand a couple of capabilities that might be in a package, but what's really good about this is Gary will go into detail about all the packages and why you would need some of those packages and what those extensions do more so than another. And in some cases, it makes sense to buy the base license and then get an extension for what you need. But in other cases, it makes sense to have move up to the entire package because of what you're modeling overall. And that's where we excel, is being able to help our customers not only solve problems, but help them maximize their software and really have the ability to model faster and save costs in the process and reach all your deadlines. So that will probably go out tomorrow, and we look forward to seeing you next Thursday. Thanks, everyone, and have a great day.